So do some projectile notes. A car is moving at 50 meters per second towards a tunnel that's 25 meters away. How long does it take to get there? So we know that delta y, delta x is equal to velocity in x direction times time. Time is going to equal 25 meters over 50 meters per second is half a second. Suppose I was to drop a ball, and then the question becomes how far does it travel in that same half a second? So I would say delta y is 1/2 at squared v0 t. I'm just dropping, so there's no initial velocity, and delta y would look like 1/2 minus 10, 0.5 squared, and if you do that out, you get, I think, 1.25 meters. So imagine you shoot an arrow parallel to the ground with a velocity of 50 meters per second towards a target that is 25 meters away. So I'm going to describe this motion using vectors. So again, I can just do exactly what I did before. There's no acceleration in the x direction. Velocity, sorry, the time it would take to get there would be the change in displacement over the velocity. So that ends up looking like 25 over 50. And there's our half a second that we had before. And then again, what's going to happen as that arrow goes, we know from experience that it's going to fall. And so what we're looking at, and this whole topic is looking at, is projectiles. So let's get a sense of how far it's going to fall. So what is this vertical distance that it's going to fall? Well, I can use this same equation. Again, the change in the y position is the initial velocity, that's 0, times 1/2 minus 10 t squared. And we know from experience, we did it a few seconds ago, that this comes out to be 1.25 meters down. So now we have a slightly same problem, but slightly different wording of it. I now fire this arrow. It falls, it's not drawn well, but it falls a distance of 3.2 meters. And so the question, we know that the distance to the target is 40 meters. And so then the question becomes, what's the velocity of the arrow? Well, we know that the velocity in the x direction is the distance in the x direction over the time, but we don't know the time. What we do know is that the distance in the y direction is given by 1/2 minus 10 t squared v0 t, no initial y velocity, so delta y is 3.2 meters, and that is equal to 1/2 minus 10, so I put a minus sign there because it fell, times t squared. And if I solve that out, I find that t is equal to 0.8 seconds. And now I can come back up to here and say, oh, if the velocity in the x direction is clearly going to be the distance that it traveled, 40 meters divided by the time it took to get there. And so the answer is going to be 40 over 0.8. Which is 50 meters per second. So a baseball is pitched horizontally at 40 meters per second. The batter is 18.3 meters away. What is the time it takes for the ball to get to the batter? So distance, change in distance in the x direction is velocity times time. So time is going to be the distance it has to go, 18.3 meters divided by its speed, 40 meters per second. That gives me a time of roughly 0.4575 seconds. And now I want to know how far the ball is going to fall in that amount of time. So distance 1/2 a t squared. I get minus 1/2 10 0.4575 quantity squared. And if you do that out, I got 1.05 meters. So that's relative. So clearly a batter is, a pitcher is not going to throw the ball horizontally, but it's going to actually understand that and throw it up a little bit of it and take that into account. Super.